One value, two IDs.
Yeah, I don't know. I have a Twitter. Twitter, and there's with my Twitter.
Yeah, I think it's
Set up my stuff and I have it on we normally chat. I guess it will be. It was better start where it's yeah, I think so. No, we have some administrative slides in there. It's pretty much in the beginning. I don't. Yeah. Who's Spencer?
Welcome to the Transport Area Open Meeting. I'm Martin Stiemerling. We need a minute taker. Volunteers from taking minutes. Thank you, Brian. And the JavaScribe who looks at the Java room if there's somebody who has questions. JavaScribe. Any JavaScribe? Thank you, Alison. So we're set. The blue sheets are going around. Please sign them and keep them going. We are waiting for Spencer. We get it.
So while we are waiting for Spencer, who has to come, it's better. That's the notewell. Use the chance to read it again if you haven't done so already. We just started, Spencer. So, well, time for reading the notewell. So the agenda for today, it's pretty full, at least on this slide. Notewell be done, blue sheets is done, JavaScript done. We have minute taker. That's the agenda. It's time to bash the agenda. We talk the first 15 minutes about administrative issues out of the area. There's nothing really hilarious to be mentioned. Then we have a small BOF announcement from Gonzalo about the court BOF. He doesn't have prepared any slide, which is a pity. And then we have a talk from Felipe about rekindling network protocol innovation with user level stacks. And at the end, we're going to use the remaining time to discuss open issues on current and future hot topics in transport. And the intention there is to see if we in transport actually covering everything we should be covering in terms of transport protocols, signaling protocols, whatever. If you have specific ideas, you are free to get to the open mic at the end and express your opinion. Do you think something is missing? Okay, then we can close bashing the agenda. We're gonna go over to the current set of working groups we still have. You can see this on the left-hand side. Those are the active working groups. And on the right-hand side, you see the groups which have been closed since the last IETF meeting. And they are just listed in the canonical order where they got closed, which is PSP, Connex, and Storm. They all have finished successfully their work. And yeah, that's it. No questions? No, it's just running away. And then Spencer made some nice pictures today about me closing working groups. And because at this IETF, we have this nice red button up here, which is the close working group button. And if something goes wrong, you just hit the button and it's gone. And Spencer was saying that's how I do it on the slow days. So, okay, good. Then we you might know or you might not know, we had an area secretary, which was Linda Dunbar. She helped us in the past in running those area meetings and getting slides together, asking for the minute takers and so. And she's stepping down as area secretary. And the main reason is we have since the last meeting or the meeting before a so-called triage team, which is Alison Menking and Wes Eddy, who are actually helping the transport ADs in running a bit reviews and so, and we just said that this task is being merged into the triage team. Thank you, Linda, for being our secretary. I know, she's in here. She's not here, no, okay. Thank you. Yeah. Right. Then I'm not sure if we announced this last time already, we talked about this. So we have now a new transport and services area review team, TSV ART, which is replacing the old transport area directorate. And right now it has like a fixed number of 13 members. So it's not me anymore, but the future ADs, which is Mirja and Spencer, might consider of growing or shrinking it. You can see the list of people who is currently on the area of a team. Thank you for volunteering, and let's see how it works out. So then that's probably something Spencer should be talking about. That's Spencer's point.
So my position is being reviewed by this year's NOMCOM. The 2015 position description is at the link on the slides. Please check to see if the current description matches your understanding. We made changes the last couple of years. We have observed that the current description worked at least once. Welcome, Mirja. So like I say, we think we have a pretty good description. We are interested in what people think, and please send comments to the TSV area list. Please start considering whether you can accept a nomination for Transport Area Director now. It is the second year of my second term, and we all know what that means.
Yeah, your turn.
Okay, I've been asked to give a brief heads up on Accord. I gave a similar one in TSVWG. How many of you were there? Okay, good. I expected.
See? It was worth doing it twice.
Yeah. Spencer was right. Actually, I mean, I thought the overlap was going to be much bigger. Anyway, so this is about the Accord BOF, and let me give you basically the same heads up that I've been giving during the week. The origin of this BOF was that basically operators started seeing a lot of encrypted traffic on the internet, and in particular on radio networks. The reasons for that, they are, manifold, but in part is the IETF actually recommending that protocols by default, they use security, and that encryption is used all the time. So the problem is like some of the techniques that they use to do radio management or management of traffic over the radio networks, they actually rely on having access to unencrypted traffic. So when the amount of traffic that is encrypted is really high, they cannot use those techniques any longer. As a consequence, actually, GSMA, which is the Association of Mobile Operators, they held a workshop with the IAB. It was called MARNU. And basically, they were discussing, how to look at the problem. They were actually checking specifically, not just so much the architectures like 3GPP, but more like what is actually deployed and what is actually in use. And actually, I would suggest that you go and read the report because it was just coming up last week, I think. And that will give you an idea of all these discussions. Those discussions were basically, scoped in a smaller group because it was an IAB workshop, and this is an IETF BOF, so the scope is much bigger. We're gonna basically, be continuing those discussions and investigating basically what are the proposals and solutions that we could use in order to address some of those problems. So, as I said, we will be discussing requirements, pain points, and potential solutions. This is a non-working group forming BOF, so if we actually come up with something that could look like a solution, as I said, for example, one of the proposals is to use DeepServe for that, it would actually come back to the right working group, or if something new would be chartered. But it will not be an Accord working group basically working on that type of thing. So it's more like, more, let's say, open-ended discussions. We want to explore the issue and see what it comes out of that. So having said that, do you have any questions, suggestions? Yeah, good point. On Thursday, the BOF is on Thursday. I forget which lot. I think it's in the morning, actually. But anyway, look in the agenda, Accord on Thursday.
Put it on the slide. Yeah, morning session.
Morning. Okay, so it's morning session. If you want to basically get familiar with that, as I said, read the Marnew report, and we have uploaded a lot of material there, presentations, slides, the agenda, so you just can go to the materials page and have a look at everything. Okay.
Thank you. Yeah, Philip, you can come to the front. It's really tempting, isn't it?
Okay, good afternoon. My name is Felipe Wisi, and I'll be talking about something we call rekindling network product stack innovation with user level stacks. So this is basically attempting to put network stacks in user space. And this is work in conjunction with people from NEC, NetApp, and a bunch of other people. So the motivation here is if we could extend layer 4 functionality, we could address a lot of problems. And there's a lot of people working on things like MPTCP, Windows scale, fast open, and so forth. There's also things like encryption, TCP crypt, and so forth. So clearly there is quite a need for improving transport protocols. But is it really possible to still deploy layer 4 extensions? We know there's a lot of middle boxes out there, but we've done some measurement studies and we show that for well-designed TCP extensions, it is still possible to deploy these new extensions over about 86% of the paths. So if the paths actually work, how come we're not able to deploy new transport layers so easily on the internet? So the actual implementations are in the OS stacks, of course. And this is for many reasons: high performance, it provides isolation between applications, and then you provide socket APIs. And then you have new OS versions that adopt these new protocols and extensions. Part of the problem is, though, that the the release cycle is pretty slow in the magnitude of years. And once you have the support in the OS you actually have installed, that doesn't mean that you're actually using it, because defaults mean that certain features are not turned on, and even when they're there, if many system admins are sort of loath to actually turn them on, because why would you fix something that isn't broken just to improve performance of X? So I don't want to really go into the details of this graph very much. I'll just give you the overview. This is basically traced from Maui from 2007 through to 2012. And what it's doing, it's measuring deployment amount of certain TCP features such as selective acknowledgements, timestamps, and window scales. And sort of this is for Windows and Linux. And some of these, such as selective acknowledgement in Windows, was deployed in Windows 2000. And you can see in the curves that even in 2012, you don't have full deployment. You have something like 75%. And some of the other features very slowly ramp up over 5, 6, 7 years. So what we're sort of aiming for is that to ease upgrade, we could move protocol stacks into user space. And of course, it would also aid in experimentation. The problem is there's no real practical way to do this. We need a couple of things. We need, obviously, isolation between the applications. We still need to support legacy applications on the system, so we still need to support the host OS stack. And we need high performance. So what we did is we built a system that sort of provides all of these. And sort of these, this is the overall architecture. So I'm going to walk you through it from bottom to top. So you have the NIC at the bottom. And then we're based on the software switch called Vale, which is the NetMap API from the University of Pisa. And inside that switch, we have a module that basically works on 3 tuples. So network stacks and applications register 3 tuples. And then this module makes sure that packets are directed to the right stacks on Rx, and on TX, and make sure it filters such that stacks don't send packets from the wrong 3 tuple. And then we add virtual ports to the switch. Those virtual ports are connected to the user level network stacks, And on top of that, we have the actual applications. The other thing to note is you can see on the right-hand side of the diagram, we still have the OSS stack, so it's still possible to have a user-level stack alongside with the standard kernel OS stack. So the features of this are, of course, we support multiple stacks. We provide namespace isolation through the standard 3-tuple. We have very high performance, and I'll show some graphs in a minute. And we run both on FreeBSD and Linux, and it's open source, and I'll give you the link later on. Okay, so to give you some performance numbers, the first thing we did is measure just raw TX with UDP packets. What we have in this diagram is the experimental setup, so this is TX. So at the very top, we implemented essentially, it's not really a stack, it's just UDP. And on top of that, we implement a packet generator, right? That sends packets as fast as possible. That connects to a ring of packets connected to the switch. And what we can do is we can create multiple of these rings, and these rings each can be assigned to a different CPU core. So we can scale the performance of this with multiple CPU cores. These packets then go down to the actual kernel module, and so the switch, and the kernel module will make sure that if that packet chain application said, I will send out of port 34, make sure that that's actually the case. So the application needs to register, make sure the port is free, the OS agrees that it is, and then it'll send packets, and the module will check that it keeps up with the registration it did. And then it goes out to the NIC. Okay? So that's the basic setup, and that's those are the results. So it's UDP, so we can do different packet sizes. And what this is showing is that for any packet size 128 and bigger, we can saturate 10 gig line rate with a single CPU core. And for minimum size packets with 2 cores, we already saturate the entire 10 gig pipe. So that's TX. And then our X, the setup is basically the same, but we're going up, and instead of a packet gen application, we're using a packet receive application. And again, we get this sort of nice curve where a single CPU core is mostly enough for most packet sizes to get the 10 gig line rate. Okay, so that was a single stack and a single application. What happens when you add multiple stacks, multiple applications, so you add more virtual ports essentially to that switch. On TX, what is essentially happening is you still have this filter checking that each port is sending out of the 3-tuple it registered with. And we see pretty much line rate. Basically, in this case, we're assigning a CPU core to each port in a round-robin fashion. And we go from 8 ports to 64 ports, and you can see in the graph that we are able to saturate the 10 gig link going out with the 4 cores that we have on the system. Okay, RX, pretty similar. And we get this graph. You can see in with 64 byte packets, as we add ports, the rate goes a little bit down. What happens here is that the reduced number of packets, there's more ports. So each time you call a syscall on each port, you receive fewer packets. The syscall has a certain overhead, and so your rate goes a little bit down, but you still get 10 gigs with those CPU cores. So the performance summary is you get 4 gigabits per second for 64 byte packets. Did you want to ask a question?
Yes. Did you mention the packet chain is this is UDP or TCP? This is UDP.
This is UDP. That's why we have the packet sizes.
Right.
Right.
So the stack code there, is this sort of a miniature? Oh, this is just UDP.
It's just UDP. So
numbers
I have
for TCP.
Right. So I have at one of the last slides, we do a minimalistic TCP stack and an HTTP server on top of that, and we have.
So it's a is it possible for you to run the real stack like the Linux stack or? Yes.
Yeah, in principle it is. The thing is that the API that the ports have is the netmap API. So as long as at the very bottom of your stack you have the netmap API, which is pretty simple, then yes, you can run that stack.
Okay, thanks.
Yeah.
Jerry Chu, Google.
Okay, so yeah, the summary. This is basically numbers from the graphs, which are not always easy to reach from the graphs themselves. It's 4 gigabits per second for minimum size packets with a single CPU core, 10 gigs for all packets with 2 CPU cores, and 10 gigs for 250 size packets with a single CPU core. Okay, so yeah, so I slightly mentioned this. So far it was a very done UDP stack. So what we did is we took what we call a micro TCP, which is a very simple TCP stack, just minimalistic TCP stack, and we built a very small HTTP server on top of that. And that's the graph. Basically, we compare this against Nginx with TSO, with the standard OS stack, because remember, we can run our user level stack on the same system as the host stack, so we can do nice comparisons. And what you can see there is that the bar all the way on the right is our bar, so micro TCP, UTCP. We can outperform the host OS stack. This is not a big surprise because our stack is doing less work. It's not so much to say that we're beating the standard TCP in the host, it's to show that we get pretty good performance in the gigabits per second, even with an HTTP server running on top. I think this is something like 100,000 requests per second, which is a decent number given that we have a sort of low-end server. Okay, so the conclusion is I presented multi-stack. It's OS support for user stacks. The idea is to be able to experiment and try to deploy new transfer protocols in a more timely fashion. I hope I convinced you that maybe it's possible. This is, of course, a research project. If you want to try it out, it's open source. The URL is there, and if you want to find out a few more details about it, there's a SICOM CCR paper that describes this in more detail. Yep.
Not just Solis, Park. A couple of questions. Number one is, did you consider a potential performance hit by the fact that you have to run multiple stacks? So in your experiments, was there just one app, maybe multi-threaded, but I guess in the OS is supporting like any number of applications running stacks, and what that performance it has for you or the OS?
Yeah, right. So the stacks in these experiments were always the same, but they were completely independent from each other, right? So they had the same weight, but you know, the experiment shows what the hit might be. Of course, the unrealistic part is that the stack is not a very heavy stack that we were using. It was a minimalistic one.
No, I mean, if you go back to your system diagram that you had before, you support multi-stacks, right? Yep. All with isolation.
Yep.
Does the fact that you support multi-stacks all with isolation come at a cost?
Very, very minimal. That's why we were having these sort of early graphs where we have a single stack, and you can get, you can get practically line rate with a single CPU core. So compare that. This is not in the presentation, but this is extensions to the value switch, and if you compare the value switch performance numbers with the multi-stack performance numbers, they're within 1%. Because ultimately what this module is doing a bit of three-tuple filtering, a bit of demuxing, and we did some extensions such that the performance scales well with the increasing number of ports.
Right, I guess this comes at the edge of the graph of performance, right? But if you, because you're in user space, you have to do more context switches between the different applications, whatever it is that you're doing, versus the kernel space being able to process everything in its own single control loop, then you end up running with
of course.
a few more performance percentage points.
Yes, right, yeah. You're going to lose something. It's probably for percentage points. That's the sort of thing we measure. But of course, you can't beat the kernel, right? Yeah.
To Google again. So the multiple instance of stacks, actually, we think it's a feature, not a bug. Actually, you got a lot of advantage, like isolation, resource accounting, and also the better cache locality.
Yeah.
So, to answer the previous person's question, we think this is an advantage. But one thing I don't know. I think it could be quite difficult to pull out the code from a real TCP stack like Linux or PSD to run, right? You have only administer TCP implementation here.
Yeah.
Right. So that's one thing I wonder how much it will,
No, I agree. I don't think it would make. I wouldn't recommend any of you to take the TCP stack out of the kernel and sort of adapt it and put it on top of that. Because that's not a trivial port, and on top of that, who would maintain that afterwards? You can do it once, you can get some nice, you can do a nice research paper out of it, but who's going to maintain that, right? What's nice about the
so
TCP
this is so we at Google we are actually very interested in this configuration, and we actually are actively pursuing the work in this area.
Okay.
I hope to
Right,
have
so the answer to my
something
question
to
is Google. When I said who would do this, it's Google, right?
But anyway, well, by the way, I know other three authors except you. So,
Okay. Yeah.
I wonder how much your benefit performance boost you get from NAP. If I just put this on on top of raw socket and going through the kernel, right, without any special hardware support, right? Do you have a guesstimate of how much? I mean, you got most of the boost from NAP.
I don't know. I mean, if you're asking me what would happen if I did this over DPDK, for instance, versus NetMap, no, I haven't done that.
DPDK is still hardware support, right?
Well, no, NetMap doesn't require any hardware support. It has some modifications to some of the drivers, but
you only need the DMUX, the hash.
Yeah, but that's not done in hardware. Right?
Yeah.
So it doesn't have any hardware support. I mean, what it does is it does take some of the Intel 10 gig cards, 1 gig cards, and it slightly modifies the network drivers, but it doesn't use any of the special hardware features in those cards, right?
I see. Okay.
Right.
So you got a lot of mileage just by doing software, changing the API.
Yeah, that's right.
That sounds interesting. Thanks.
Jana Iyengar. Hi, Felipe.
Hi, how are you?
I love this work. I've read the paper when it came out a while ago, and it's excellent. And I think this is definitely a general direction in which the industry is moving. There are very strong clues that it's happening. But the way this work is scoped, I read it every time I read it, and I find it smooth sailing, and then I hit some friction, and I want to just tease that out. The motivations are very clear. That there's stagnancy in sort of protocol deployment and in evolving operating system stacks. The solution, however, seems to be something that allows for rapid deployment on the server side, which is not the critical block right now. Right? The blockages are largely happening in client-side operating systems, which we can't push forward. And to that extent, again, TCP as a protocol does figure into that problem. The extensibility of TCP is limited. Changing TCP because it's inside the operating system on the client side is limited. And you know that I'm biased because I work on Quick and wanting to.
That's fine. So we've had these discussions internally before. So you've hit one of the nails in the head. So for sure, one of the problems is you require this kernel module, right? And as you say, what should be targeted is not servers or data centers where you have control of stuff anyways. You should be targeting end clients, right? Windows users, Linux users at home, on laptops, whatever. And for those, they would need NetMap running on them. You would need and they don't have that, right? You can't ask them to run that. So FreeBSD, yes, because it's upstream, and it's just a matter of turning it on. Linux, Luigi has had less success in putting that upstream because well, basically, Luigi has a bit of glue between FreeBSD and Linux code, and it sort of runs at great performance, and it works well, but it's not, strictly speaking, Linux-like code, and the Linux community won't accept it.
And now we've covered about 5 people.
Yeah.
Between FreeBSD and Linux. Go on.
Yeah, so for FreeBSD, I can sort of fudge a story about, just turn it on, even if you're an end user. For Linux, and never mind Windows, you're absolutely right.
So I do have a suggestion also. This wasn't just like I wasn't trying to dump on your work.
Okay.
Right? But because I do like that this work is being done in the public, and I think it's an excellent use of NetMap as well. So I would love to see more work that looks at UDP performance.
Okay.
Because
UDP performance.
I'm sorry?
UDP performance?
UDP.
Yeah.
Because not just Quick, but there are proposals, there are ideas that people now are thinking about building transports on top of UDP. And you said that the client-side operating system was a block, and I'd say that it's not just the client-side, it's really the middle boxes that are blocking. Even Windows 10 now has upgrades every year, so you'll be able to ship upgrades to the kernel also every year, but nobody's going to be upgrading those boxes in the middle. So we have a long tail there to go, and I would love to see more work on sort of optimizing server-side and client-side performance for UDP-based transports. That work, I think, would be fantastic to see happen.
Yeah, you're absolutely right. And in the paper, we didn't go into that argument too much because middle boxes and UDP don't like each other too much. But we use UDP a lot, especially in performance work, because it's deterministic. We can specify packet sizes. TCP is a much more complicated beast when you're trying to sort of tease out what the underlying performance is.
Right. Thank you.
Yeah, you're welcome.
Christian Wittema, Microsoft. Well, I mean, this is really interesting work, and I like it. And as you said, it's really easy to deploy on a server or something like that. It makes a ton of sense.
Yeah.
On the graph that you showed initially about the deployment of TCP options,
Yeah.
the blocker is not really that it was not implemented in the operating system. The blocker, as Jana said, is that the reason it was not turned on is that when you turn it on, you get a lot of failure due to a variety of firewalls and NATs and stuff like that.
Yeah.
And whether you put it in the operating system or in the application, it's not going to change that very much. I mean, Quick does change that somewhat by sending encrypted packets. And having encrypted packets makes you failure proof. I mean, it's very interesting from that point of view.
Yeah.
But unless you do something like encryption of the packet and move to new protocols, I mean, the impact on the middle box will basically slow the innovation in all cases.
Yeah. Yeah. So in the paper, we use the term well-designed extensions to mean not just anything you want to put out there, because the middle boxes will drop a whole lot of things. But yeah, you're absolutely right. And this is one graph, but there's an IMC paper from a few years back that explains a lot of effects, including the ones you're mentioning.
Then when you go to the client side,
yeah,
there is another problem, is that when we do a user level stack, that means that the stack is now a library inside the application. And that means that your path to update is by updating the application.
Yeah.
There are some applications that get updated frequently.
Yeah.
But a whole lot of them don't.
Yeah. Yeah. So part of the work that wasn't here was to use sort of fast APIs, EPOS, things like that, and put a sort of glue in between such that you have to change the application only once. But then you tell me you still have to change the application, and absolutely, it's an open problem. Yeah.
So yeah, that's kind of an avenue for research, because you have this tension. I mean, the good point about changing the operating system is that you update all the old application in one fell swoop.
Yeah.
And so it's.
I completely agree. I don't know if it would be possible to create an automated tool that, because ultimately the application, you only need to change small bits of it, sort of the bottom layers of the network calls. I don't know if it would be able to automate the modification of that, changing the code such that you can modify to apply to, in this case, the NetMap API or some sort of high-speed API. I think, well, you would need the source code. That would become the next problem, but I think you could probably automate parts of that adaptation layer.
Well, we kind of see that with OpenSSL right now.
Mm-hmm.
You have a bunch of applications ship OpenSSL inside the application. And when you have a bug in OpenSSL, you get to update all of those. So it's kind of the same thing.
Yeah, I understand. Fair enough.
Nacho Souls Park. There's kind of this funny tussle that we're presenting, at least it's funny to me, for the group as a whole. Right now, you're describing having this user space stack, which I'm 100% in favor of. At least these questions like Christian was mentioning on having potentially the stack built into your application and maybe not being able to upgrade or whatnot. But basically what you're doing is you're defining a type of API underneath you. But in your case, you're pushing NetMap or whatever you're pushing, or somebody might be pushing DPDK,
right,
or whatever it is. And you might imagine having some library that goes into the OS, sees if it has support for NetMap or DPDK or something, instantiates its own stack and uses that to communicate.
Yeah.
At the same time, we're working on things like taps, right? We're trying to abstract from a higher level above what we're providing underneath.
Yeah.
Right. So we just divided our API into two and carved ourselves off a little spot, a little box, that we now try to make and interoperate with the rest of the network, right? That has the issue of not allowing this protocols to evolve, right? And we're basically fighting on three fronts: underneath, above and basically to the network side.
Yeah.
Which I don't know, it's a funny tussle that we're trying to fight against, which does present for the community a good opportunity, but a big fight, right? Because everybody in different layers has their own interested things that point towards.
Yeah, absolutely. It's completely a tussle. I mean, the stuff we work on is only on two of those fronts, which is either compatibility with Sockets API or high performance with some other packet IO framework such as DPDK and NetMap, and pick one. What do you want? You want compatibility or you want speed? Take a pick. We pick speed, but then we're not compatible anymore, and then you need to change the applications. And what do? That's why I was suggesting maybe you can do you can do an abstraction layer. That's one of the things I was suggesting, which is what you're working on. And then, but then people have to comply with that abstraction layer, but it's already better than our approach in terms of compatibility. But maybe you sacrifice a little bit of performance. Maybe you don't. Who knows?
I think performance at the OS side will be okay. I mean, the client side is not going to have that issue, right? And the server, you can optimize the hell out of it, right. Whether it was custom hardware or software. Right. But it is an interesting tussle, and you're basically providing, in your case, weapons, right? Yep. So we can fight and actually now have a way to start deploying and figuring it out. And in the case of Google Space, right, they have their own controlling both sides to try to figure out in the middle. But it is very, very interesting. So I'm highly in favor, and I think we should continue doing the work, and maybe some of us will join on the different sides of this tussle.
Thank you.
Janai Engar again. So I said something earlier that I recommend that you look at UDP performance. I wanted to ask you if you actually had, and I had a more specific recommendation. Have you looked at the difference so with NetMap and with the stack, have you actually looked at performance over UDP versus TCP and how different they are? And actually, with respect to one thing, I'm assuming you're using some sort of TSO style offload.
For some of the TCP ones, yes.
Yes.
At the end of the presentation, but all the other base tests are UDP, yeah.
Okay.
Right, so what I can tell you is not in this work, but some of the other stuff that we build high-speed virtualized content caches. And we still use the NetMap API for those. And yes, you must absolutely turn TSO on, otherwise you're going to die.
So in the interest of thinking about evolving protocols on UDP, that is a limitation that still stands.
Yep.
Right? So there's scope there for work that needs to be done in terms of figuring out how to reduce that cost. When you're doing offload, how can you get something that's equivalent to TSO for generic UDP-based transports?
Yeah, completely. Yeah, I agree.
Thanks.
Hi, Brian Dremel. I think I've already actually told you like a year ago when you were working on the paper that I like this work. I still like the work. So I wanted to go back to one thing you said about sort of like UDP versus TCP middle box interference. It's actually way more complicated than that. I'd like to tell you to go grab your favorite time machine and come back to the MapRG session yesterday because we're doing some sort of active measurement on trying to tease this out. And it's actually a lot more complicated. UDP and TCP are broken in different ways by middle boxes in the internet. A second thing that I wanted to say, there's currently some work going on in the Stack Evolution program. It's basically, I guess to go back to Nacho, we're another group of people who are going to use the weapons you're providing us in a slightly different way. Okay. So I'd encourage you to actually take a look at that to continue working on this work, and we'll be in touch.
Okay.
So, thanks.
Yeah, thanks a lot. Yeah, and on the first statement, I tried to summarize a 12-page IMC paper about middle boxes in one sentence, and I think I failed.
Yeah, I think the sentence I was is it's complicated.
Yeah, it's really complicated. I agree.
Thank you very much.
Thanks.
Just give me the thing. You want to say something on this slide? I mean, do you want to say something or should I say something? That kind of works, right? Okay. So we have another about, I guess, 40 minutes to talk about current and future hot topics in Tsvarea. And what we like you guys to do is to think about, what's the hot topics you've been talking about to others in the hallways or in site meetings, and let the larger community know, or what's the hot topics you would like to discuss in the IETF in future? What do you think is missing, from outside that should be discussed in the IETF? Also, we were hoping that there are maybe a couple of people in this meeting who are not usually only active in the transport area, but also in other areas. So if you think you've seen something over the last 2 days, basically, in a different area that can be interesting to the transport area, please let us know. Please come to Mike and let us know. Or if you have seen something in a completely different forum, in a conference or in another standardization organization, which is interesting for transport, come to the mic and let us know. I guess one part is what we already started discussing with the previous presentation is stack evolution. And as previously summarized already, there's a lot of things going on like tabs, but also in other areas. And I could imagine that some of you have additional thoughts on this.
Hi, I'm Al Morton. I'm going to bring up a topic which all I had to do was mention at a workshop last year, and Randy Bush came to another microphone and yelled "rat hole." So it's speed measurement, and I think that there's certainly an interaction between what is being developed for the future of transport and what we will ultimately measure for speed. I think we can figure out how to measure the speed of IP packet transfer. But the minute you go anywhere above that and start to have significance for user applications, it's a very complicated problem. We've been working on this for a while. Matt Mathis, of course, and others have been tackling this for years. But we're on the verge now where the regulators are not going to leave us alone anymore. And we need to have something that we can all agree on here, I believe, that is going to be useful and relevant and fair to the service providers. And it may mean that there are multiple methods of measurement to do that in the end. But I think that's, it's unfortunate that we may have to do this more quickly than we would like, but I think that's one of the hot topics, at least as a service provider. I have to, I'm having to deal with this more often than I want to now. Thanks.
Christian Wittema from Microsoft. You're asking what kind of interesting stuff we could do, what's popping that is new. At a high level, what is very new is not new, but it's a new focus. It's the focus on latency. A lot of the work that was done in transport historically has been on the fair sharing of resource and achieving a fair sharing of bandwidth in particular. But we did not really have a focus on latency. If you look at the controls we have in TCP and things like that, they are not oriented towards latency. If you look at the way slow start, for example, behaves in high bandwidth throughput network, it creates huge spikes in latency. There are things like that that we see. And if we did say, hey, what are all the things that we are doing in the various way we tune the transports that contribute to increasing the latency in the network, then we could probably have a lot of interesting action. Of course, one thing we are doing is the work on active queue management. but we have very little synchronization between the active queue management and the evolution of transport. For example, there was Bob's message about FQ Cuddle explaining how deploying fair queuing in a router is going to actually pessimize your performance if a lot of your traffic is background traffic that would have otherwise slowed down. So this business of latency, management of latency in the network, interference with the transport, that's something that we can probably study quite a bit.
Hi, Brian Trammell. Mainly I got up here because I wanted to yell rat hole at Al. And then he took the rat hole and he threw a bunch of lawyers in it, which makes it even more fun. And then Christian said something about latency. And then I remembered there was this workshop that ISOC did a few years ago about sort of like reducing internet latency. I think it was ISOC and Wright put this together. It was in some dreadful hotel in London that was different than the dreadful hotel in London that we were in for the IETF. And there was a little sort of side conversation that went nowhere there. It was, how do you measure latency of an access network so that you can actually give service providers something other than the one-dimensional number that they can compete on? And we got nowhere with it. And I think that it might be a rat hole filled with rat holes filled with lawyers. But going beyond sort of like the basic so step one is going beyond the basic IP transport measurement to, you know, something on top of that. And then step two is then getting some sort of number that talks about the interaction between latency and and capacity. I mean, there's been a lot of emphasis on reducing buffer bloat, and that's been good. I think the idea that some queue is good, therefore more queue is better, and therefore all the queue is the best. We've kind of managed to beat that out of the industry, or at least the bits of the industry that listen to us. But it would be interesting to go into, okay, well, what are the other points along that curve other than just what we can get through reducing the queue and being a little bit smarter about how we use it. I'm going to have to sit down and think about what Christian just said about making the transport evolution work better with the AQM. But I will note that there's a lot of things that we're thinking about sort of in the SPUD work. For those of you who are interested in it, we just did some new documents. We posted the links to those to the SPUD and the Stack Evo Discuss lists yesterday, where we're talking about sort of knobs that you can put on the traffic that are essentially like the traffic expressing its preferences about the AQM thresholds it would like to see. So we're at the very beginning of that, but I don't think we have anything like, I don't even have consensus with myself as to whether or not the stuff we're thinking about there is correct. But I think that might be an interesting thing to dig into a little bit deeper.
So before you run away, I just thought when you said we had this latency workshop a while ago, a couple of years ago, we should actually go back and look at the report and see which, because we listed to-dos at that point of time, and like one to-do was, for example, supporting ECN support.
Yep.
Another one was AQM. I think this was like the starting point of the AQM working group, and there were other to-do. So we should probably have a look at it, and maybe you just want to post a link to the report on the mailing list.
If I can find it, and then if I can make sure that there aren't to-dos that are still pending that I said I would do.
So, Gary Fairhurst, responding a little bit to Christian, I kind of buy what he said, but I also don't believe that we do transports really for fairness. Fairness is just kind of a thing that comes because we don't want starvation, we don't want congestion collapse. So it's more of a mechanism. And in FQ Cuddle is flow queuing, the idea being that we don't provide starvation. And I think these things are so important. And one of the things we seem to be missing is combining things like DiffServ and AQM with ECN and putting this together as a package to try and solve some of the problems we're seeing other people propose much more exotic solutions for. I think we have a number of good techniques, and it's the fairness thing, the idea of competing with traffic is just came about in the past, but now we have better techniques, and we have ways of doing this, and I think we just need to explore these. Everybody, that is. That's not those people on the platform.
I think this is partly the scope of the Accord Borf as well. So I hope we will have more discussion on this in the Accord Borf on Thursday. Let me give it another try. I would super curious to hear if people think they have seen in a non-transport working group something super interesting. People should, let's make a show hands. Who has visited a non-transport working group in the last 2 days? And BOFs don't count. Okay, not too many. Okay, we need to bring more other people in this meeting. Okay. So last chance to go to the mic. 3, 2, 1. So then we're done. Thank you very much.
Thank you all, and we'll see you in Berlin.
Yes. For Martin, yes.
Yeah, thanks to Martin. Right. Yeah, 24.
24 hours away from freedom. I'm gonna do like sort of run downstairs and then slide on my knees.
I want to see that. Bring a camera.
Oh, my poor knees. Call your wife and say you have to pick him up at the airport. Yeah. Yeah. We're going to propose at the next meeting that this is not the mute button, the mute button should be yellow. The little red button for the speaker.
Stop the speaker.
Chapter or what?
But I guess they.
This is the presenter. Well, I mean,